Good afternoon, good morning, or good evening, depending on where you are joining us from around the world. Welcome to the second session of our Emerging Nuclear Technologies webinar series, proudly hosted by Women in Nuclear Innovation and Win for Peace groups of expertise of Win Global. So on behalf of the group, I'm Florencia Renteria from Mexico. I'm a PhD in nuclear science and technology and a former IE Fellow of Technical Cooperation Departments, program for supporting nuclear power infrastructure, capacity building in member states, and one of the WiNI co-leaders of Win Global. So today we gather to explore how AI and digital twins are transforming the construction, deployment, and operation of nuclear power plants. These technologies are not just reshaping engineering practices, they are redefining the future of clean energy, safety, and innovation. We are honored to have leading experts from Westinghouse and Accenture with us, and we look forward to a dynamic exchange of ideas that will inspire new paths in nuclear advancements. So this webinar brings together global experts to explore how emerging technologies like AI and digital twins are transforming nuclear power through innovation in construction, operation, analytics. This is our program for today, and I would like to start introducing the great two moderators we have for today's session. So first of all, allow me to introduce Oli Pajare is a member of Women in Nuclear for Peace, a law reform and a legislative drafting practitioner with over 12 years of experience in legislative projects in Zambia, where she has involved in drafting different types of legislation on different subject matters. She is a holder of a master's degree in nuclear safeguards and postgraduate diploma in nuclear law for the University of Montpellier. She currently serves as a board member of the National Health Research Authority and the Radiation Protection Authority, and a committee member for various law review committees, including the Electoral Reforms Technical Committee for the review of the electoral legislation and policy. She has served in various positions, including as the Deputy Chief Parliamentary Counsel, responsible for drafting various legislations in the Ministry of Justice. Olipa is currently the Assistant Commissioner, Revision of Laws in the Ministry of Justice and serves as capacity building and legal advisor at Nuclear Aware Africa and a board member for the National Prosecution Authority in Zambia. For the second part, we have Jeanette Lama Osako. Is a seasoned nuclear professional with over 2 decades of experience at the General Commission for Atomic Energy and the Regional Center for Nuclear Studies in Kinshasa, Democratic Republic of Congo. She currently leads the Documentation and Archiving Unit, and she serves as division head at the Ministry of Higher Education, University, Scientific Research, and Innovations in the Democratic Republic of Congo, and as the president of WIN Democratic Republic of Congo chapter, an active member for peace member, Jeanette is deeply committed to advancing nuclear knowledge, promoting gender equity in science, and fostering international collaboration in nuclear applications. So before I hand over to Olipa, I would like to introduce first a little bit about our groups of our innovation groups of expertise. So WiNI was launched and created in September 2021 under the framework of the partnership between Win Global and World Nuclear Association, being Dr. Sama Bilbao and Leon, the godmother of WiNI initiative. WiNI aims to promote and strengthen the involvement of women in nuclear innovation in the sector and to enhance the attractiveness of the nuclear energy as an innovative and cutting-edge technology in the sector, especially for the next generation. Through different activities like panel discussion, and training courses technology for the future of the energy sector, promoting public understanding and raising the sector's profiles. And the group currently has 21 group members representing different regions of the world. Its events are announcing on social media and by email, and they are open to everyone. Of past events are available on the Win Global YouTube channel. So if you miss any of our previous or past events, please go to the Win Global YouTube channel and revisit the materials available. So Olipa, please, the floor is yours. Thank you.
Thank you, Florencia. Thank you so much. Good morning, good afternoon, and good evening to everyone that has joined us. You're welcome. So my name's Oli Pajere, as introduced. I'm from Zambia. So I'll be your moderator for this session. But briefly, I'll just talk to you about WIN for Peace. So WIN for Peace was established in 2023 to contribute towards world peace through the involvement of more women in the areas of nuclear non-proliferation, safeguards, export controls, and disarmaments. So this group conducts mainly coordinated activities across all 4 domains, and in particular by organizing webinars and workshops. The group has about 30 members from 4 continents and is currently led by Eva Guine, who is who has joined this meeting. Thank you so much, Eva, and is also a technical leader of WIN Global. So its supporters are the Vienna Center for Disarmament and Non-Proliferation and the UN Office for Disarmament Affairs at Vienna. So its events are announced on social media and by email, and they are open to everyone. And recordings also of past webinars are available on the WIN Global website and YouTube channel. So throughout these discussions, our panelists will provide their expertise, share experiences, and offer recommendations based on their rich experiences in the nuclear energy industry. Before we begin, I would like to remind everyone that this discussion is being recorded, and we'll also have a quick question and answer session at the end, so please do not hesitate to ask your questions. We have an impressive lineup of experts who will share their insights and perspectives on today's topic. At this moment, let's take a brief moment to introduce our first panelist. So our first panelist will be talking to us on AI, advanced construction techniques for nuclear power plants deployment and operation, and is no other than Lou Martinez, who is the Chief Technology Officer, Executive Vice President, R&D and Innovation at Westinghouse, USA. As Chief Technology Officer at Westinghouse, Lou leads the company's global research and development portfolio and advances the company's innovative product and services technology strategy. She also serves as acting president of eVinci Microreactor, a leading Westinghouse standalone global business for the innovative microreactor technology, with a focus on advanced design, commercialization, manufacturing, and deployment. Lou has more than 20 years of experience, and having worked in senior leadership positions in the energy, biotech, automotive, and architecture, engineering, and construction industries. And most recently, Lou was Executive Vice President of Strategy Innovation at Kairos Power, with additional oversight of the supply and procurement, marketing, and communications team. Previously, Lou has served as the Chief Innovation Officer at SPY Batigonios and Vice President of Global Innovation at Framatome. Lou graduated from Ramon University in Barcelona, Spain, and obtained a Master's of Science degree in Physiology and Biomechanics, as well as Human Factors in France. Additionally, Lou holds a doctorate degree in Public Health, Environment, and Sustainability from Côte d'Azur University. Lou is also a Master Black Belt Lean Six Sigma certified by the Ohio State University in the United States. Lou, over to you. Thank you very much.
Hi, thank you all for hosting us today, and welcome everybody to this webinar. As you present, Jerry, I'm Lou Martinez, and today I will share how AI and advanced digital technologies are transforming our nuclear construction. Next slide, please. Just an overview of what is Westinghouse. So it's a global company. It's a leader in nuclear energy. We have over 90 facilities in 21 countries and more than 11,000 employees. And one fact that is always very impactful is that Westinghouse technology generates nearly 50% of the world's nuclear power. We focus on outage, maintenance, services, fuels, and as well as delivering, constructing new power plants. And that is what we are gonna really focus today. Another fact that I would like to share about Westinghouse is that it's a company that is over 140 years old. And we have been able to navigate the different innovation waves to be where we are today. AI is one of those very disruptive technologies that are actually reshaping how the company is going to deliver in these businesses, specifically in how we're going to deliver the construction piece of the new power plants. That is the focus of the webinar today. Can we go to the next one, please? So I'm sure everybody knows this is something that we have been discussing in different forums, but I think it's important to recall that the world demands, it is requiring more nuclear, but traditionally construction delays have created huge costs, overruns, and risk in the delivery of new power plants wherever we are in the world. Basically, for over 20 years, we stopped actually building large reactors. And now we need to start again all that knowledge transfer and capabilities to deliver the power in large, but also on the SMR, the small modular reactor sectors. Basically, three items that are very important. First is the capital intensity that goes into the civil works. Again, from an SMR or for a large water reactors, still 60% of a nuclear plant is capex, and is still related the high level of uncertainty on the delivery. It is related to the construction piece. Why? Specifically for the AP1000s, that is the technology that Westinghouse it is currently deploying. There is still that risk. The rest, we still have a lot of lessons learned from the 6 plants that are currently operating worldwide, 2 in the US and the rest in Asia. However, that 60% of uncertainty that is still being on the construction side, when we see the numbers that you see on the slide and where they are expecting us to deliver, is very critical to utilize new technologies as AI and digitalization to actually deliver on those plans. So basically, we are in an era where we can phrase it in this way: what AI is doing for nuclear and what nuclear actually can do for AI in the developments that they are happening. Next one, please. So we are seeing that AI, as I was mentioning, represent that 60% of risk on the capex side, and 20% of the experience that we have is actually delays. One of the reasons in Westinghouse that we start thinking how we can deliver differently. So we start developing modular construction, utilizing digitalization in the full chain of value, from the design till the construction until the operations. The AP1000s are fully modular design. It's very complex to construct modular if you do not have design for modularity. So even large reactors, they are being built, at least the AP1000, with modular construction based in a unified digital platform that allows a good communication between the different stakeholders. Basically, us that are the designers, but also with the shipyard builders that they build the models, and the constructor on site when they are actually assembling them on site when they arrive. So we develop a platform that is preparatory to Westinghouse that is called WNexus, that basically allows for that continuity on the digital side to reduce that 60% of risk that we're still seeing in construction. However, we realize through all the lessons learned that we do in the AP1000s that they are currently operating and has been being built in the recent years, that there is a gap on that digital continuity with the constructor. And there is ways where if everything is digital and all the modulars, they are in a single platform, actually we can leverage AI to optimize and dramatically de-risk the nuclear new construction. Can we move to the next one, please? Next one, please. So in Westinghouse, we develop our nuclear-specific AI, is what you are seeing on the slide. It's called Hive. And Hive is actually a preparatory infrastructure for our nuclear-specific AI. We have our own LLM that is called Bertha, that allow us actually to develop in a very secure environment or AI and leveraging the 75 years of data and expertise that we have. I don't know what is going on with the slides. They're moving around, but if we can go back to the slide 6, that will be great. Thank you. So in this, utilizing our own infrastructure, we built a partnership with Google Cloud because we needed extra technology bricks to allow us to keep de-risking the nuclear construction with AI. How it works, I would like to go to the next slide. If doesn't stop moving, slide 7, how actually it works. The challenge is that we have to build new nuclear, such the AP1000s, and actually we need to build in by fleets. It's not just one and the other. And as I was mentioning before, they are fully modular. And what you are seeing here on the first square is that they are fully digitalized. The idea was how we can utilize Hive with very competitive tools coming from Google to take all W Nexus digital design platform to transform the 3D models directly into working packages. And that is what you're seeing on the middle of this slide, is that approach. First, we need to transform the data and bringing it back into a database that can be shared. So we need a data source that is actually the good, that is shared with the different actors when we are building. Secondly, we need to optimize the work packages delivering. So we need to build an optimization tool that allow us actually to understand when I arrive to the work construction site, what are the risks that I'm going to have today, how I can adapt my schedule to the configuration of the workshop that I have in the day. What are the impacts? The impacts are shorten the construction schedules, reduce the cost, but even more, it is really analyzing the visibility of that digital continuity so everybody at the same time is sharing the same data. Our idea is really to improve the scalability and the repeatability and the lessons learned of each one of these. So with AI, we can not only transform the construction or advanced reactors, but it's also about the efficiency and the know-how transfer and how we connect the experts about themselves. So it's really one of the game changers that we believe is going to allow us to deliver more nuclear gigawatts into the grid according to the new market needs. We can go to the next slide. That just is a small eye. Earlier this year, Databricks awarded Westinghouse with the 2025 Data Intelligence Award for Energy and Utilities because of the very astounding work that we are doing. My point here is that we are not doing it alone. We have a technology brick, approach that allow us to what we call in our jargon open innovation and collaborate with different partners and actors, including the utilities as well. It is true that having this kind of awards for a nuclear company, and I know probably some of you are not aware about Databricks and these AI summits, but it's really an accomplishment and it showcases how important nuclear it is today in the world of AI. To deliver actually a clean power. So I would like really to thank you all for your attention. I hope this short presentation has shown the journey in how advanced analytics, AI, cloud technologies are really transforming the nuclear construction for the next generation. And again, this is applicable for big reactors, small reactors, or micro reactors. Thank you all.
Thank you so much, Lou. That was a very insightful presentation. Thank you. I'm sure our attendees have got quite some interesting questions for you. Thank you once more. So we now move on to our second speaker, and who is no other than Jane Wong, who is a Principal Director and the National Power Generation Leader at Accenture Canada, where she advises utilities on digital transformation, advanced analytics, and the adoption of emerging technologies. With more than 20 years of nuclear industry experience, she has held senior leadership roles in engineering, IT, and capital projects, contributing to major programs such as nuclear refurbishment and SMR new builds. Her current work currently focuses on applying digital twins and advanced digital solutions to enhance reliability, efficiency, and innovation in utilities. Jennifer is also a plenary co-chair of the Canadian Nuclear Society's Disruptive, Innovative, and Emerging Technologies Committee and a former advisor to the Canadian Standards Association on emerging cybersecurity and digital technologies. She also serves on the board of governors of an independent all-girls school in Toronto, where she chairs the Diversity, Equity, and Inclusion Committee. Today, Jennifer will be speaking to us on driving innovation in nuclear, leveraging digital twins for operational excellence. Jennifer, please, over to you. Thank you.
Thank you for the wonderful introduction. I'm just going to take a second here to share my screen, and hopefully we can get my slides up shortly. All right, is everyone able to see that?
Perfect.
Yes, we're good.
You.
Perfect.
Okay, thank you for the introduction, and I'm honored to be here today to speak to a group of female leaders and also female leader allies who are interested in learning about technology and the way in which the world is evolving. I also listened to Lou Martinez's presentation with a lot of interest because I do believe that with the rising demand of nuclear and the need for more energy growth, technology is going to be an important enabler in all of that. So before I jump into my presentation, my name is Jennifer Wong. I lead the power generation practice at Accenture in Canada. As many of you are aware, Accenture is a global consulting firm. It probably exists in the country that you're connecting in from today. We are 900,000 employees strong throughout the world, and we offer consulting services across many different areas, including technology, strategy, cybersecurity, and capital projects. So for myself specifically, I sit in the energy utilities consulting practice, where we're providing consulting for new build projects, refurbishment projects, and also operational excellence for existing plants. Okay, so I'm going to jump right into my presentation, and I'm going to start off with defining what a digital twin is. There's many different definitions of it, and you've probably heard of the term in many different contexts. Very simply, I'd like to think of a digital twin as a virtual representation of a physical asset or a physical plant process system. And this can manifest itself in different ways. But more commonly, there is a virtual representation that is married with plant process information. So real-time data coming from IoT sensors, giving you real-time indications of plant parameters such as pressure, flow rate, and temperature. And then more increasingly, also, it is a virtual representation that is married with engineering information. So, what is your equipment tag? What is the bill of materials? What is the design manual or the tech spec that is associated with that piece of equipment? It provides you a single pane of glass view into your plant. So at any one time, when you're clicking on a pump or you're clicking on a valve, you can pull up its engineering specs, and you can also see in real time how well that asset is performing. What are some pending work orders? What are some things the operators should watch out for, which is a real game changer in the nuclear industry. As many of you who work in nuclear plants know, nuclear is a very regulated space. A lot of these systems have been built up over time, and some even before the advent of modern day digital technologies. So you can imagine that as we're refurbishing the plant and adding new systems, you end up with a hodgepodge of technologies from different decades, right? It's almost like going to a museum and walking through different eras in time. So as a result of that, a lot of these systems don't talk to each other or share information with each other. And as an engineer who's working at the plant, you have the tough job of understanding how your system is performing and what the health of that system is. So that often means looking into different systems, spending time to pull out documentation and drawings, and then trying to figure out what is really happening. Not the most efficient way to work, and there are modern day technologies that can, really transform the way we perform our work and bring us into a more efficient environment where you're able to see what is going on and you're able to plan your work more effectively and efficiently. So that is what at the heart a digital twin is and what it is possible of enabling us to do. Okay, so building on this concept of a digital twin, you've probably also heard of the term digital thread. So this is the concept of, it's great if you have this digital twin in the virtual space, but how do you link it through the evolution of a capital project or the evolution of a design of a plant system over time? So this concept of a digital thread is that even though when we think about the digital or the virtual environment, it's a moment in time. But what is powerful about the digital thread is maintaining the history of that digital twin. So you can rewind in time or fast forward in time to understand how did the evolution of your construction take place, or how did the design decisions occur along the way, and what were the foundational aspects that you based your design on. So this concept of a digital thread that connects the dots between project planning to design to construction to commissioning and then finally to plant operations is an important one. The ability to link up these stories over time so human can still apply judgment and understand what is happening at your plant at any moment in time. Okay, so now that we know what a digital twin is and also what a digital thread is, what is the value proposition? Why should we think about the digital twin and why it is important? As I mentioned before, this concept of a digital twin, a digital thread, is important because it allows you to trace through the evolution of your plant. So for the new build plants, it's understanding what were the design basis of the plant when you first designed it. How was it constructed? How was the plant left in terms of as built? And then what was finally turned over to the owner operator? And when you think about the evolution of that for a new build plant, it could be maybe 5-10 years in a country that has a very efficient regulations, or maybe 20-30 years for a larger nuclear plant or for a highly regulated country. So when you think about that evolution for capital project, it is quite significant, and it's easy to lose the design foundations of your plant along the way. So this concept of a digital twin and digital thread as you're building up your plant is important because it allows you to capture that information efficiently, and also from all the multitude of partners that are involved in your new build. So your constructor, your architect, engineer, your owner operator, it ensures there is a way to enable that communication and capture that information so that it's preserved in time. And then, coming out of the new build and going into the operating environment, you're looking at a plant that is going to operate for the next couple decades. So again, preserving that history, having all the information in one place and at your fingertips, that is highly important. If we're going to build more and we're going to build faster, we also have to unlock human efficiencies, right? How do we free up the time that it currently takes to look up drawings and tech specs and building materials to give engineers more time to do creative work and creative planning work? So, there's a lot of value in the digital twin. It requires a little bit of upfront investment and lots of planning, but the value is definitely there, and I think is a key enabler if we're going to drive growth over the next couple decades. Okay, so with that said, how do you get started on a digital twin? This is not an easy journey, and we have a lot of clients that are really interested in it, and they're wondering where do they begin. They're operating a plant that has been operational since the 1970s. They've retrofitted the plants in some areas, but they don't really have a cohesive data strategy or a single repository with all their data that's structured in a consistent way. And we tell our clients that, you know, it's almost impossible to have the perfect environment to digital twin. And what is more important is that you start the journey and you understand what are the key value areas that are going to bring the highest return on investment for you. And that could be digitizing some portions of the plant that are you know, the most aging or the most prone to failure, or it could be investing in a new capital project that is going to add a high return in value. So I think there are, you know, I think there is a place to start for everyone, but it's important to understand what is the most strategic, and you're not going to be digitizing, you know, your whole plant from day one. So you always start with sort of, you know, looking at what the high value places are, and then you start creating that digital twin. And that digital twin is not going to be perfect from day one either. It's going to be a representation, and maybe it's just a visual representation at first, with maybe just your you know, your tech specs and your bill of materials and your equipment tags integrated to it. But over time, you build up that maturity of the digital twin, right? You start off from maybe your design basis information, then you layer in your operational information so you can see real-time data. And then eventually you integrate, you know, some aspects of AI where it becomes an intelligent twin. And you're able to use it for things like predictive maintenance, where, you know, potentially instead of, you know, doing a preventive maintenance routine on a pump 2 times a year, you're able to say, well, this pump is actually performing very well based on its historical data and based on our understanding of where it is on the bathtub curve. We think that maybe we can reduce that preventive maintenance schedule to maybe 1 time a year. So you get into, you know, very interesting areas like predictive maintenance, where, you know, you're able to really fine tune what is the optimal maintenance schedule for equipment, and reduce your operating costs as well. So you know, so this concept of a digital twin and the journey to get there is not easy, but you can start small, look at one system or one asset, and then build up that digital twin along the way. So speaking of maturity, we often think about the digital twin maturity journey in 5 stages. As I mentioned before, you know, in the most simplest of states, it's a digital model. It's a 3D representation, or maybe even sometimes a 2D representation of a system. You know, we use the term digital twin, but when you think about it, this is not really a novel concept. You know, in the nuclear industry, we're quite familiar with simulators, for example, where, you know, since a couple of decades ago, we've been able to simulate systems and understand how they work. So, you know, so at the most basic level, you know, you have a digital model of your system. And then if you progress the maturity of that, you're starting to look at passive digital twins, where you have your digital model and you also have real-time data that's integrated into it. So again, this is something that I think is quite common at the nuclear power plants, where you're seeing real-time indications from our sensors. And maybe it's through a system like Pi, where you're able to see at any point in time how well a particular piece of equipment is doing, and whether or not you're at risk of crossing a alarm threshold. And this is beyond the control room. This is a business system where engineers can log into it at their desk and see how their system is performing at any one time. So that's sort of your level 2. And then if we're going into the area of level 3, this is where we're starting to look at things like predictive analytics and insights. We call that the dynamic twin, where you're able to apply some kind of intelligence to predict when a system or equipment might fail. And you're able to make some informed human decisions about it. And then progressing along that maturity curve, you have the intelligent twin next, which is not only is the twin able to have some kind of predictive ability, but also ability to learn from what it is seeing. It's able to provide you some recommendations, like, you know, maybe you know, maintaining that pump twice a year is not the best way. Maybe once a year is sufficient. So it's able to provide some type of recommendation to allow you to tweak plant performance. So this is sort of like your level 4 intelligent twin. And then finally, level 5, which is, I think, a concept that is that requires some caution in nuclear, and that's the concept of a autonomous digital twin. So this is a digital twin that is able to understand what's going on, provide predictive capability, use autonomous decision making, and also control and action. So this is something that, we see in industries like manufacturing and production, but in high risk and highly regulated industries like nuclear, it's an area that requires a lot of thoughtful research and also, thoughtful discussion around how this might look. But this is the range of digital twins are within our graphs. And I think certainly, a lot of nuclear power plants are at like at level 1 or at a level 2, where you have some kind of digital representation of your plant systems. You have real-time data, so you understand what's happening. And really, the next frontier for nuclear is using that data to start making intelligent decisions. So how do I tweak my maintenance schedule? How do I plan my outage work and sequence them in a logical way that optimizes safety and performance? And then beyond that, it's going to be in the area of AI. How do we start using AI for AI to provide some intelligent recommendations for a human to provide some judgment and decision making on? So we definitely live in some exciting times here, and I think the next couple of decades are going to be just so fascinating in nuclear. And as we're building more nuclear power plants, we're learning, technology is evolving. So I think the landscape is going to change pretty drastically in the next couple of years. Okay, digital twin use cases for projects and operations. We talked a lot about that, so I'm not going to go in too much detail around this. But just really briefly, as Lou Martinez mentioned, I also think digital twins have a lot of value to provide in the new build construction side of things as well, in addition to plant operations. I think the ability to collaborate in a common data environment between multiple parties, your EPC vendors, your owner, operator, and also your and also the reactor OEM and all your manufacturers or suppliers. I think as these SMR and new build projects become more expansive and we're scaling globally, it's going to be very important to work in a common data environment where the data structures and the way in which we're tagging information and thinking about information has some consistency. So I think that's something that the industry needs to look into in order to have some type of harmonization. And I also think in terms of this increasingly global environment, it's going to be very important for our regulators to work together to think about, what is the regulatory framework that makes sense in order for us to accelerate innovation, but also with speed and caution, with safety being our priority. I was just at a workshop last week, actually, with the NEA and the IEA and regulators from the UK, Canada, Japan, Korea, and some of the utilities, where we were exploring that exact topic, right? If we were to look at the expansion of AI, for things like calibration sensors, calibrating sensors, or for informing predictive maintenance. What are the barriers that exist today in terms of technology and regulatory gaps? And how do we need to work together to address that and enable our utilities to innovate and grow? So there will be a paper published by the NEA for that sometime next year. So please be on the lookout for the outputs of that report. Okay, my last slide here is around value. So we talked a lot about the benefits of these use cases, both for new build construction and also for plant operations. And if I look more broadly outside of nuclear to other industries like oil and gas that have adopted more readily, what are the cost savings that we're seeing in the space? At a high level, we're seeing that plants are able to achieve a 3 to 5% reduction in OM&A costs. We see that large capital projects are able to increase their capacity by 3 to 5%. And we're also able to see that engineering construction labor hours are on average reduced by 5 to 10%. So I think those are some really exciting data points. And nuclear, the ranges may be a little bit different for nuclear, given how regulated we are as an industry, but the cost reductions are there. And I think it's very important that we start exploring it. We need to start somewhere. The data may not be perfect, and we may not have all the data, but if we choose a high value use case and start building our digital twin from there, I think there's a lot of potential, even for our old plants and not just new ones. Okay, thank you for listening to my presentation, and I look forward to the Q&A next.
Thank you so much, Jennifer. That was a very interesting and insightful presentation. At this moment, I will hand over to Jeanette, who will take us through the Q&A session. Jeanette, please, over to you. Thank you.
Yes, Olipa. Thank you. Let me thank our speakers for their very, very informative presentation. If I have a look to our chats, I see we have 3 questions. The first and the second, I think that is addressed to Lou. The first one comes from Bevan Enan. Excuse me for the pronunciation. The question is, what model do you use for the optimization process? The question is addressed to Lou. And the second one from Emily Lucas. She asked, how has large-scale power demand increases for private companies, Google, Amazon, developing AI, developing alternative funding approaches for large capital, large-scale nuclear projects? I think that it's the 2 questions are addressed to Lou. And I have one question for you, Lou, but I'll let you I'll let you first answer to those 2 questions.
Thank you, Jeanette, and thank you for the 2 people that has asked the questions. One is very, very technical. So as I mentioned, in Westinghouse, we have what I call a technology brick approach. So we utilize different tools, but actually we also develop our own tools and we assemble them in a very specific way. So the basics of our Hive, that is our AI infrastructure, it is based on Databricks and the WiNI catalog technology that actually is a lakehouse that allow us to start all the bind there. Then on the optimization side is a combination between on Bertha, that is on large language model. And for the optimization, we utilize Vertex from Google. And it's a combination of those technobricks that actually fits very well with our own technology. Jennifer was discussing about the digital twins. And one of the things that is very important on the digital twin is the combination between real hardware and the data. And this is the value that actually we have in Westinghouse because we have built already those reactors. So our W Nexus is the platform that allows us actually to optimize and play with the different tools. But I give you some of the names already. So basically it's tools coming from Databricks, tools coming also from Google. And we are in a hybrid cloud application based on Azure with Microsoft. Our technology, how we use it, is fully compliant with the regulator in the United States, in the UK, and in Canada, because we have a lot of governance goes into that. So it goes beyond how to optimize, because if you are not compliant on the regulation, you cannot use it. Second question is more strategic. So I'm sure you have been reading a bit the news, and I'm sorry for more or global colleagues. This is much more US centric, but it has been really a big change in the last 2 years because the big hyperscalers, Google, Amazon, Meta, Microsoft, they are starting to see that, it's very interesting when you go to their presentation and they present what in the AI jargon we call the full AI stack. It starts with energy. So it is very critical for them to scale up those capabilities to have nuclear, how those investments are happening. It's the first time in the nuclear energy that we are seeing PPAs. PPAs is a kind of new contract that usually renewables use, but nuclear usually were not on those kind of contracts. What it means that you purchase power ahead of time for a number of years. And that actually makes the utilities feel much more comfortable and the financial community, because the customer of those large reactors or SMRs, they are already there. So they already, these hyperscalers say, if you are able to build all these, I will pay this price of LCOE, leverage cost of energy, at this price for this number of years, that usually is between 15 to 20 years. So that is actually how the hyperscalers currently, they are reshaping a bit the energy side. And I'm sure in other countries, we're going to start seeing the same, because the data centers, they are not only in the United States, they are in all the countries around the world where the capability of producing energy is there, and the data is moving with those data centers. Jeanette, back to you. You told me you have another question. You are on mute.
Excuse me. Yes, my
Yes.
little question to Lou is, how do you address cybersecurity concerns when implementing AI in critical nuclear systems?
Jeanette, is a very good question. It's not easy. So how we do it in Westinghouse is that we introduce those requirements from the beginning of any project that we do. So we have two teams in cybersecurity, one that works more on the innovation side, try to find what are the actually new technologies that I can use to secure a public cloud. If you are not able to do that, it's very difficult to run agentic AI or generative AI on that. And then we have our IT systems colleagues that they do a lot of audits to check that what we are doing actually is fully compliance. And we have created a governance committee with our compliance colleagues from the legal side, or IT colleagues. And then we have a very open dialogue with the regulators, where actually we are applying those tools. So we keep them fully informed in what are the technologies. Obviously, I cannot reveal the secrets in how we do it, but basically we have dedicated teams that from the beginning of the innovation, when you are utilizing or thinking about AI, the cybersecurity team, it is included on that development. So it is very critical, and I really like the question, because without nuclear safety, without cybersecurity in nuclear, we cannot operate.
Yes.
So it is a constraint,
Yes.
or a limitation that we have, but instead of seeing as a limitation, we can see it as an opportunity to interact differently in those areas. What I have seen in the past is that sometimes innovators, as I have on my team, they are very excited, very passionate, and I'm going to use this. And suddenly arrive the regulator or the cybersecurity colleagues and say, no, you cannot do that, because you are putting at risk this. So what I'm trying to do culturally is introducing it from the very, very beginning of the innovation funnel. So we work really as a cross-functional team, integrating the cybersecurity and the regulatory framework from the beginning. It's slowdowns, but actually you win a lot of time on the implementation, especially when you go to a customer or to a regulator.
Thank you, Lou. Thank you. My question was little, but the answer was very big. Thank you. So we go to Jen. I saw that we have 3 questions. The first one from Mamen Salas Cortez. Sorry for the pronunciation. He asked, do you think that digital twins of new nuclear plants should be mandatory? That's the first question for Jen. The second one from Fatima Tijani Shehu. She thanks for your presentation, but she asks if you think it will be possible for them I understand that she's from Nigeria, for us to have the three powers in Nigeria? And what do we need to develop if from human to technical resource? And the last one is from ID Zhang. The question, no, not the last, I see another. Is there a working group, regular platform for companies like Westinghouse to work together with regulators for IA applications? I don't know if you can stop there or I give the all questions. Can you answer first so we can take the, I see, well, yes.
Yes.
Can you answer for those three?
Yes, Jenna, I can definitely start off, and Lou, feel free to jump in at any point in time. Can make this a little bit more engaging. So I think the first question was around, do I think digital twins should be mandatory for nuclear power plants? I think that's a tough question. I think it depends on how much governments and companies want to invest. But certainly, I've seen that some owner operators have started to write digital requirements into their contracts. So they're requiring vendors to do their designs in 3Ds, to capture design information all in a common data environment. So we're seeing an increasingly number of owner operators who choose to mandate that to their vendors. And I think that is a wise choice, because if we're thinking about the future and needing to modernize the way we work and modernize the way we build and run these plants, it really begins with the data. So I think some kind of requirement or some kind of obligation to provide data between suppliers and OEMs to the owner operator, I think that is sound. And I also think that for large capital projects, some countries, such as the UK, have started to mandate digital environments like BIM, for example, for certain projects of a particular size. And that's also a prudent decision. When you're working on a large project, of course, there's a lot of risks that need to be managed. And if you're able to transact in a environment that's more structured with data that's well understood by everyone, then you certainly reduce their risk. So I think making digital twins mandatory, that's a strong word. But I think owner operators should think about how do they decrease their capital and operating risk? And then more importantly, how does technology fit into that equation? Lou, anything else that you'd like to jump in and add?
No, Jennifer, very well said, and I agree with you that mandatory is not usually the right path, because every project is very different, every power plant is very different. But what is clear is that the digital continuity and the digital twin is kind of the master of all that putting together. It is more than mandatory; it's a necessity. Especially if you want to deliver on cost, on target, on a schedule, if you want to operate the current fleets. So all the industry is moving towards it, but more for a necessity than actually something that is mandatory.
Jeanette, what
Thank
is the next
you.
question?
The next question, let me see. I think that's from Fatima. She asks if you think that it will be possible for them to have the twin powers in Nigeria, and what they need to develop if from human to technical resource. Question from Fatima.
Fatima, thank you for your question, Fatima. I think the human and technology resource is an interesting one, and I think it's something that everyone is thinking about. How is the human going to change as AI becomes more ingrained into our work? And what are the core and emerging skill sets that nuclear engineers and nuclear plant operators need to develop? I think that when we're looking at what AI can enable, a lot of the day-to-day administrative tasks, a lot of work that we would normally think an analyst would do, for example, all of that AI can do very readily. But I think at the heart of it, you still need, the creative insights and the human sound judgments that really turn the day-to-day Monday task into something more great, right? So when I think about data and AI, it's unlocking the ability for humans to spend more time in doing creative and more productive work. If we think about the last big technology change for humankind, I would probably say it might have been the advent of the internet, right? And many of us here on this call will remember how that changed our lives and how email changed the way we do our work. I don't think it made humans redundant, and I don't think it fundamentally changed the value that humans add, but it certainly enabled us to do our work more efficiently. So instead of going to the library to read 10 or 15 books, we went online to do our research. And now we're publishing, more papers, we're enabling more innovation, we're being more efficient at what we do. I think AI is going to be the same way, where we're just unlocking more human creativity in order to drive even more innovation. So I think it's important for companies to start thinking about that. And Accenture actually has been quite aggressive in adopting AI. You've probably heard, our CEO Julie Sweet speak about that. She is mandating the use of AI for all our consultants, and it's not a question of if and when we're ready to adopt. It's the timing is now, and everyone has to be ready to embrace.
Thank you. Thank you, Jen. So we take two questions from Emily. How has large scale power demand increases from private companies? I don't know if you already answered. I don't know. How has large scale power demand increases from private companies? For example, Google, Amazon developing IA. I think that this question already answered. Yes, I think so. Though we take from question from Marwa. Her question from Jen. If you are starting your journey in the nuclear field today as part of this new generation, what's one thing you would do differently given all the IA and digital tools now available?
Thank you for that question. I think that the nuclear workforce that is coming out of school today needs to be very agile. And needs to have an open mind. AI is disrupting the way we work, but it's going to be here to stay. And I think that as part of this generation coming out of school, you need to be able to have a ready and open mind. And also, when you think about the nuclear industry, it's not just your traditional engineering path or your traditional path to become an operator or technician. I think that technology is starting to blur some of these roles. So even between like IT and OT, right, we see those two spaces emerging. IT analysts and engineers working hand in hand and sometimes working in the same space. So I think that the ability to be agile in the adoption of technology and having an open mind to roles are becoming more blended, will serve you very well. I also think that universities are starting to change their curriculum as well. When we're looking at McMaster University in Canada, for example, they've started to introduce some nuclear programming into their liberal arts courses in recognition that in order for the nuclear industry to really move forward, it's not going to be just a team of engineers and scientists. It's going to be the whole ecosystem, right? It's going to be people who understand policy and politics, people who understand Indigenous relations, people who understand the public and how to communicate. So I think it's that well-roundedness that is really going to be needed for the next generation to succeed in many aspects. And no longer, can you just be an engineer who wants to be in the technical lane and nothing else? Although those jobs still exist, but I think to really move the industry forward, you need to be agile, both in the adoption of technology and also open-minded to roles that are becoming more blurred and more diverse.
Thank you. Magdalena asked two questions, so I will merge the questions. She said, how much effort or time does it take to implement the full process? How long does digital twin take time? the last one, she wants to know, how does a digital twin work? Who is in control of a digital twin? And since IA can be part of a digital twin, who ensures or proves that IA is implementing the right things? Very good question. Yes.
So yeah, I can start off answering, and Lou, feel free to jump in. I think that at the end of the day, the human is the person that is in full control of the digital twin, and also what guardrails humans want to be put in place so that the digital twin or AI is making the right decisions. Of course, there's a lot of discussion right now around the traceability of AI and also the trustworthiness of AI. Some of us have probably been on ChatGPT and been in cases where you start getting hallucinations and results are not accurate. So I think it's very important that humans are still in the loop in one form or another, either in the learning and development of models or in the refinement of results or applying human judgment to the to the end decision. I think it's no different. The way I think about it is I don't think it's any different from traditional software categories per se, where we're looking at safety impacts and consequences, right? If we're using AI to make a business decision with no safety implant or plant impact, it's akin to using Copilot to make meeting minutes, for example. Then we may be able to relax some of our guardrails. But if we're looking at putting AI in the plans where we're potentially making a decision that can indirectly impact a plant system or directly impact the way a plant is operating, then I think you need to start applying increasing levels of rigor. So it really depends on how you plan to use the AI, what the impacts and failure consequences are. And I think that framework of thinking around that in the nuclear industry is quite mature. So I know a lot of the regulators are looking at how do we apply some of those frameworks to regulate AI? And I think it's a good place to start. And sorry, Jeanette, what was the question before that? I missed the question before that one.
Uh, I think that we can stop with question, but the question from Bajon, I think that is addressed to both of you, Lou and Jen. He has, do you foresee a large demand for nuclear engineers in the coming years, months, to manage or run these nuclear energy projects? I think that even Lou or Jane, you can answer to this question.
Lou, please go ahead.
Sure, I can start. I mean, it is the first time that I'm seeing a market traction by nuclear that is this high. So the answer is absolutely yes. We're going to need a lot of resources, not only from nuclear engineering, any kind of engineering, business colleagues, legal colleagues, people working on public acceptance. When we see the number of gigawatts that actually all these new technologies are asking us to build. And that is another reason why AI is so critical, because the idea is actually to enable and empower the engineers, especially the entry levels, with the knowledge that their peers they have. When you are a subject expert matters, you cannot have that level of expertise in huge amounts. But the young engineers that they are coming to the workforce, they need to have access to that knowledge. And that is when AI, it is actually super critical to enable the workforce, because basically we empower the engineers. We free them time with the tasks that doesn't add value to the ones that actually they do. And we help also to introduce that learning core much faster from the subject matter experts. Basically, your AI is your agent that is helping you actually to do your work better. I would like also to point to the previous discussion, Jennifer, that at least in Westinghouse, there are a lot of things we are not allowed to do with AI, because the decision is always coming from the engineer. So To the question, do we need those resources? Absolutely, yes. Because at the end of the day, it's the engineer that make the decision. It's not the AI, it's not the digital twin. The digital twin and the AI helps accessing the data in a way that facilitates actually your work. And that combination between new workforce coming to nuclear that is really, really needed in big amounts worldwide, link with the power of AI is what is going to allow us actually to deliver the gigawatts in nuclear power that are being requested by the market. Back to you, Jennifer.
I have nothing else to add. Thank you.
Yes, Jen, do you something to say? Jen, no?
No, I have nothing else to add. Thank you.
Thank you. So I see that there are many questions, but our time is over. So can I ask to Florencia to take those questions and to address them to the speakers so that she can transmit the answers. For me, I think that we can stop here. Olipa, I get it over you. Thank you. Olipa, I finished.
Oh, thank you very much, Jeanette, for that very wonderful session. Florencia, you may close for us, please. Thank you so much.
Thank you so much, ladies. And of course, we will collect the questions and then send it over to Lou and Jennifer as well. They can help us to reply offline to the participants, and we'll be sending the information to the participants as well. So just to thank Lou Martinez, her team in Westinghouse, as well as Jennifer, her team in Accenture, and all the external and internal supporters that make this program possible, from Win for Peace team and as well as WiNI Group, all the contributors. We really thank you for all the organization and all the framework for this program. So thank you all for joining us in this insightful session. The discussions today have highlighted the immense potential of AI and digital twins in driving operational excellence and innovation in nuclear energy. As we continue this webinar series, we invite you to stay engaged, share your perspectives, and collaborate across borders to shape a smarter, safer, and more sustainable nuclear future. So don't forget to register for upcoming webinar sessions, not only from the WiNI group, but also Win for Peace and the rest of the events of the groups of expertise. And let's keep the momentum ongoing. Until next time, stay curious and stay connected. So thank you very much all, and we wish you to have a very good rest of your day or evening, depending where you are. Thank you.
Thank you, Florencia. Thank you, everyone.
Thank you, everyone.
Thank you.
Thank you.
Thank you, Lou. Thank you, Gina. Thank you, Mrs. Eva, everyone. Bye-bye.